Welcome back. Today we're going to be talking about running functions in SQL, specifically Oracle SQL, so we can do some queries that ask questions about strings. Again, we're working with Oracle, so that means when we're running these queries, I'm using the dual table. And if you haven't used it before, the dual table is how in Oracle you can make a query without having a referring data set that you're working with underneath. It's used to perform quick calculations or demonstration purposes, like what I'm doing right now. And so that's what we'll be working with. So if you have any questions as to the source of where I'm getting the data from, these are all values that are just literally typed into the screen, but we're using the dual table as the source for those queries. If you're practicing these same queries using the appropriate functions on other database engines, say for example MySQL and MariaDB, instead you'll simply just do select and the resulting query using the function that you're working with instead of having the from dual on that. That's just if you're not using an Oracle system, but since I'm using Oracle for class, that's what I'm using on my demonstrations. Hope this is helpful. Let's go ahead and get started and use some of the queries right now. We're going to be working with a couple different functions to demonstrate how we can work with strings using Oracle SQL. Specifically, we're working with the inster, the subster, the padding functions, as well as how to do concatenation with strings inside Oracle SQL. So those are what we're going to be going through as we work with that. So just as a quick idea, that's what we're going to be covering as we do that. We'll come back and review these as we go through it. But again, we're working with how to look inside a string, how to get parts of a string out, how to pad a string, as well as how to join strings together. And that's what we're going to be going as our process as we work through this today. Let's first take a look at the inster function or the inString function. This is similar to what you'd see if you're working with Java for the index of function. And so as we can see right here, we have select inster, and then I have my name, Cody Henriksen, comma OD as inster demo. Again, whenever we're running a query that uses something that provides information that's not simply a column name, when we're working with that, we always want to use the as keyword and rename our results, because when we're sharing that information out, we want to make sure that we're providing only the appropriate information. And especially when we're doing something like, say, for example, a function or something that reveals the structure of a table that we don't want to share outside of what we're doing, or if we have a really complex thing, that makes it look really messy over down here in our results column, or when we're trying to share this with a result set for another program, like say, for example, we're building a query that will then be called by a controller inside maybe a Java, a C# or C++ program. We don't want to have some potential problems with information being shared out of that. So you always want to make sure that you're, every time you use a function, use the as keyword to appropriately limit those results that you give to the user. And so we have select inster, which is in string, and then Cody Henriksen, the first parameter is the source that we're looking through. The second parameter is what we're looking for, that little subtext that we're looking for inside that string. And again, I'm using from dual for all these queries. So I run that query right here, and it's going to run it, and it's going to say, hey, OD is at 2. Well, the reason it's at 2 is because when we're in database land, we start talking and counting at spot 1 for everything we're working with. I know if you're coming from a regular programming land, it's a little bit different, but in database land, we always start counting at 1. So C is 1, O is 2, D is 3, and odd, OD, happens first at right there, spot 2. And so that's what odd inster demo gives us back as a result. Now, because we start counting at 1, if we do not find the result of that in there, we'll give a different value back. So I look instead of odd, I look for just the letter Z. And so if code is Z anywhere inside Cody Henriksen, and so I run that same query again, and as you can see, when I run a value that's not found as a second parameter, it returns a value of 0 for the result. And so if you don't find something using inster, it means it doesn't exist, and it gives us a value of 0. So unlike with Java, which gives a -1 for its index of or failure, and we're working with database land using Oracle's SQL, we have inster gives us back a 0 because that's before the beginning of the string. When we're using the inster function, the first parameter is the text we're searching through, and the second parameter is the text we're searching for, and it will return back the first time it sees it. And if it can't find it, it'll give us back a 0, as we see right here with the demonstration on screen. Next, we're going to take a look at the substring functions. Our substring functions is how I look and extract data out of a string. We often need to extract data from strings when we're working with databases, or even just strings in general. And so we want to extract data out of this because of the fact that Daft Punk just recently called it quits. I'm using Daft Punk as a source for what we're working for in our video today. And so I have a select, and I have subster Daft Punk 5 as basic substring, subster Daft Punk 3.4 as my intermediate substring, Daft Punk -4 as my reverse substring, Daft Punk -7, 2 as my reverse plus substring, and finally, my Daft Punk -70 as my unused substring. We'll take a look at what those 5 different clauses do, or functions do, as we actually execute them, so we can see what's going to happen. We'll go ahead and run the query right here. And as you can see in my results, I have my basic gives me space punk as a result. And so again, when we're talking with strings in database land, we start counting at 1. So I have daft is 4, obviously. So 1, 2, 3, 4, and that 5th character is this space right there. So that's included with it. So when I use the substring, it's an inclusive structure, and a single parameter goes from the number specified all the way to the end. So I get space punk as my result for my basic substring. My second substring, my intermediate substring, is a traveling one. So I'm going to go over 3, so D, A, F, including F, and I'm going to go forward 4 spaces. So F, T, space, P, and that gives me my featuring P for my intermediate substring result. I can also reverse through it. I can traverse this backwards. And so -4, I'm going to start over here at punk. I'm going to start K, N, U, P, grab that, gives me punk, and so that's my reverse substring. I go back 4 characters and I grab that entire result. My reverse plus, I'm going to go back 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. I'm going to go forward 2. 1, 2, and I just get as my result. However, on my substring with Daft Punk -7, 0, it's unused. I get this blank value. But if I run that same query right here, if I run this as a result, you can see that my unused, it's not actually blank, it's null. And I don't want to use that because getting a null value is never helpful. We want to avoid nulls as a general rule when we're talking about database design, queries, and programming. So this is one you would never want to do because if you give a value less than 1 right here, it's just going to give you back null. Ew, yuck. We won't do that, so let's not. And so again, when we're doing this, we always want to make sure we run the queries right here. So these 4 right here, using the different patterns of using a single parameter to go to the end, going here and go 3 and go 4, this parameter start at this index and go that far forward. If I give it a negative number, I'm going to go back that far. And again, if I give it a negative number, I can still go forward a specific amount. And that in this case, it's 2. However, what makes it really cool, if I give it a number that's too big, like this case, say 20, it's not going to crash, it's not going to burn. Instead, it's just going to go to the end, which is great. So I don't have to worry about getting index out of bounds exceptions like I would if I'm using substring in a programming language like Java. That's one of the cool features we have when we're working with databases. It doesn't care if it goes out of bounds. It just grabs it till the end and says, okay, cool, we're good. So that's how we can use substring using Oracle SQL. So again, that's the next thing we can have with that. Our next set of queries we're going to work with is one that we don't usually use as much anymore. And we're talking about running queries inside a database where we're going to give information that we'll work with, say, for example, in modern programming land, because most of the time we're not simply just exporting results to a console or to a paper form, like a printer. Printing data? Well, it still happens. Sometimes there are old reports that actually need that information. They expect to be passed in a certain form. But a lot of times you're going to be passing your results to something that's going to be processed in another way so you can extract the data more directly. And so the pad functions, though, are historically more of use that way. But we want to see how we can actually work with them. And so I have select rpad and lpad right here. And this is to pad from the right and pad from left associatively. And so our first one we have is on both these lpad and rpad parameters. The first parameter is the source. The second parameter is the width that we're working for. And the third parameter is what we're padding with. And of course, since I'm always using a function, I always have an as on that because I'm giving it more information. Daft Punk is no longer reality is when I'm looking for that lovely header right here. I know it's kind of chilly, but cheesy, but hey, it's all good. And so I have comp sci is, and then padding to 30, and then space nifty. And my lpad is hashtag csrocks, 20 wide, and with spaces. And so if I run that query right here, you can see that Daft Punk is no longer reality right there as the top header. And then I have computer science is nifty, nifty, nifty. Yes, it is. It's really pretty cool. So we can do some cool stuff with that. So when I'm using the rpad right here, I take that nifty and I repeat that until I get the desired width right here, in this case, 30. So it makes it so it's going to repeat that concept as many times until I get to 30 characters wide for the results of that actual string. The lpad right here, hashtag csrocks 20 space, means I'm going to make this pad from the left over here, giving me a right justified effect with spaces. And so it's a really cool way if you want to do some formatting on that. I can use that with the lpad right there to pad that with spaces so it fits because of the result so it looks like that. And so that's where we can use with rpad and lpad. Now, if I give this, for example, a smaller value than what would actually fit in it, in this case, 3, and I run that same query again, you'll notice that my reality, instead of being csrocks, it's just hashtag cs. Because computer science is still pretty cool, but if you use a value that's smaller than the source itself, it's just simply going to trim that down to that amount. And so the rpad function or the lpad function both operate in the same structure. The first parameter is what we use as the source, usually a column value, not simply just a string literal. The second parameter is the width we want to specify. And again, if it's too small, it simply just trims that down to make it fit. And finally, the third parameter is what we're going to use to pad the result to meet that condition right here, that width on the middle column. And that is what we use as the padding value for it. And if I make it smaller, it doesn't do anything anyway. So that's okay. And again, of course, I use the as for that. The next one we're going to be taking a look at is the idea of concatenation. Concatenation, however, is a little bit different. Instead of using the Oracle function concat, we're instead going to use the much a more effective way of using the pipe key operator. The double pipe keys with then a single quote and what we want to put in between it, most times spaces, since we're putting values together. Instead we'll use that, so I have join columns, pipe key, and then space, pipe key, and the next column I'm going to work with pipes, and then using double quotes around that to grab that value. And it's not concat, gives us this lovely result right here, where I'm going to join columns with pipes, not concat. It's a much more effective way of joining values because you can join multiple values at once using a single structure, and makes it really clean and easy to organize that. It's almost like using the plus operator when we're working with Java strings. So that's why I really support using the idea of using the pipe key space inside single quotes to work together, because you can really make a lot more organized and a lot easier to put together text using that instead of using the concat function. So again, we looked at how we could use the inster to search through strings, substr so we could get the substring out of values. We looked at padding, and finally how we can, instead of using the concat function, we use the pipe keys to concatenate values together. And again, we always want to make sure when we're using the dual table, because when we're using with Oracle, the dual table is how you do simple operations without looking at a bottom data set. And every time I use a function, I always want to make sure I use the as and a relevant table name, or excuse me, I use as and a relevant column name so I can properly get the values appropriate on there. Thanks again. Hope this is a great time. Have a great day. We'll see you next time. Cheers.